Good day, I'm Dr. T and welcome to my dining room table. So today I'd like to talk a little bit about carbon dating and with a question that's about carbon dating. So in this question we have, if a wood bowl has an abundance of C14 that is 12.5%, the word of, of that found in living trees, how old, I think there's a comma there maybe, how old is the bowl? The half-life of carbon-14 is 5,730 years. Okay, so this is actually making a couple of assumptions, but for what we're doing, fine. In living trees, if you actually are doing carbon dating, the amount of carbon-14 does fluctuate a little bit in the atmosphere, and that is one of the reasons why those values need to be calibrated. So of living trees now may not be entirely relevant. Thus, we conveniently have dead trees going back thousands and thousands of years, so we can calculate and compare and calibrate our results with those aforementioned dead trees. But we're not doing that. And by the way, you know how old a dead tree is by its tree rings. Yeah, nice and convenient. Yeah, also the other assumption is we're assuming that the carbon-14 started decaying when the tree was cut down. That's valid, but that doesn't actually mean the bowl was made then. We just know that the bowl was made from wood that was cut down on the date that we found, or you know, around the time that we found, not that the bowl was made there. That said, I mean, that's a pretty decent assumption, but something you do have to make and you have to caveat. You know, there's foragers that are using, you know, Renaissance era paintings, removing the paint and repainting on some other painting to make it look like a forgery that'll pass carbon-14 tests because the canvas that it's painted on is authentic. Okay, so in this case, conveniently, this number is very useful. This guy is 1/8. Okay, there are two ways to deal with dating and radioactive decay. One is with half-lives. Now that is very easy to do, but it has to land on a half-life. If it doesn't land on a half-life, you can't use it. The other one is a log-based system. Now, this is 1/8. That means it's a power of 1/2. Meaning we can use the half-life system. And typically that's the only one I focus on. If you need the other log-based system, you know, go look up the equation and do it. Okay, so 1/8. So that would be 1/2 times 1/2 times 1/2. That equals an eighth. That means there's been 3 half-lives. So after 5,730 years, it went down to half. After another 5,730 years, it went down to a quarter. After 5,730 more years, it went down to an eighth, and that's what we have. So for half-lives, we figure out how many half-lives we've got, because that's how many there are in an eighth. And, well, we just have to add them up. So 5,730 times 3 gives me big number. Let's see, 17190. So 17,000, not quite 200 years. Yeah, so that's an old bowl. Yeah. Okay, so there's the answer. And yeah, fairly straightforward. So with that said, I'll see you in later videos and have a wonderful day.